Section 5, Consumer Equilibrium. Here we will combine the concept of indifference curves with the budget constraint to identify the utility maximizing bundle. Here are the specific subsections. I've already talked about the utility maximizing bundle. We'll also look at consumer response to changes in income and how the consumer responds to changes in price. Determining the consumer's equilibrium bundle of goods. By combining indifference curves with the budget constraint, we illustrate the choice of the most preferred and affordable bundle. You can look at what's happening over here. These are the different indifference curves for a given consumer, and we've talked about the fact that as we move northeast, the consumer is happier. And just to reinforce a point that I've made before, we need to have quantities of goods on the X and Y axis. We will continue with the same items that we've talked about before, where we've said quantity of milk is on the Y axis, quantity of bread is on the X axis. So a consumer would like to have as much milk and as much bread as possible. But there is a budget constraint which is indicated by this red line over here. We've talked about the fact that given this budget, the budget constraint tells us or gives us the bounds or boundary. We need to find the indifference curve or the highest possible indifference curve, and that is this particular curve over here. We need to find the point where the budget constraint line is tangential to a particular indifference curve. That tangent is, or that condition where the budget constraint touches a particular indifference curve happens here at point E. This means that point E is the optimal consumption bundle. It makes the consumer as happy as possible given his particular constraint. Let's consider a scenario. Say the price of milk is 10, the price of bread is 20, and you are at a point where the marginal rate of substitution of bread for milk is 2. Is your budget optimized? Here we are going to combine what we have learnt in the last two sections. Marginal rate of substitution bread for milk is 2. What does this mean? Recall, bread or the item that is written first is the x-axis item, so that is good. Milk is the y-axis. What does 2 mean? This means that we are at a point such that the slope is 2. So if I were to just draw the indifference curve where we have milk and bread, we are saying that we are at a point such that the slope is 2. Now we are also given these prices, but we are not given the income. However, if you were careful about earlier questions, you would realize that you can come up with the slope of the budget constraint simply by looking at the two prices, and I'll illustrate this. Let's say that just for this particular example, the income is 100 or the budget is 100. What's this point over here? This point is 100 divided by the price of milk, 100 over 10, which is 10. And what about this point? This is 100 divided by the price of bread. Price of bread is 20. So this point is equal to 5. What is the slope? It is 10 over 5, which is 2. Another way of coming up with the slope is to simply take the price of the x-axis item, which is bread in this case. So we could do price of bread divided by price of milk. Price of bread is 20, price of milk is 10, so the slope is equal to 2. In other words, given these two prices, you can come up with the slope. Strictly speaking, the slope is -2, but we are going to use the absolute value of the slope, which is 2. Notice that at this point of tangency, the slope of the budget line 2 needs to be equal to the slope of the tangent over here. Essentially, the budget constraint line is the tangent. So if we are told that the marginal rate of substitution is 2, that means that the absolute value of the slope over here is 2. We have established that the slope of the budget constraint line is 2. Since these two numbers are the same, so this is equal to the price of bread over price of milk, that means that our budget is being optimized. So to put this in formal terms, we can say that the budget is optimized if the slope given by the price of the x-axis item divided by the price of the y-axis item is equal to the marginal rate of substitution of x-axis item for y-axis item. So I've just replaced x for bread and y for milk. This is something that could have been derived by you, but I'm just making it explicit. Now I want you to do example 5 from the curriculum. Section 5.2, here we look at consumer response to changes in income for a normal good and an inferior good. If you recall from an earlier reading, a normal good is one where if the income goes up, then the quantity demanded of that particular item goes up, all else equal. So let's say that we are looking at two goods, X and Y. And if this is a normal good, then what will happen? First, I will just refresh your memory. So we have a particular budget constraint given by the red line over here, and then we have indifference curves. This is our optimal point. So the quantity of X consumed is over here. Let's say that this quantity is 10, quantity of Y consumed is 5, but we are going to focus on X. What happens when the income goes up? As we've seen before, when the income goes up, that means that our budget constraint shifts northeast. That means that now we can be on a higher indifference curve. So we are now on this particular indifference curve. And what happens to the quantity of X? Notice the quantity of X goes up. So let's say it goes up from 10 to 12. Since an increase in income resulted in a higher quantity for X, we can say that X is a normal good. What about an inferior good? With an inferior good, let's say that originally we were at this point over here. So again, quantity of X on the x-axis, quantity of Y on the y-axis. Originally, let's say we were at a quantity of 12 and there was a particular income that we had. If income goes up and we are at a new point such that the quantity now is actually down, then we say this is an inferior good. And you know this now, the income effect or higher income will cause less consumption of good X. This is an inferior good. Section 5.3 distinguishes between an elastic response and an inelastic response. And again, recall from the previous reading, an elastic response is one where a change in price, let's say a small change in price, will cause a big change in quantity demanded, whereas an inelastic response is one where a large change in price only causes a small change in quantity demanded. So going back to bread and milk, again we have quantity of bread on the x-axis, quantity of milk on the y-axis. What happens if the price of bread goes down? We know that the quantity of bread will go up, but by how much? And that depends on our preference for bread relative to milk. So let's say we are originally at this particular point, and when the price of bread goes down, then our budget constraint shifts. Why? Because let's say if originally the price of bread was 10 and our budget was 100, then this would be 100 over 10, which is 10. If now the price of bread goes down to 5, then obviously this point is higher. So if the price of bread is now 5, then 100 over 5 would be 20. So this dotted line represents the new budget constraint when the price of bread is down. This also means that we can now be on a higher indifference curve. So if we have a situation where we have moved from this quantity over here to a much higher quantity, so now our optimal point is over here. This is a substantial increase in quantity, and that is a elastic response. What about an inelastic response? Here, notice the same sort of situation where originally we had a budget constraint, price of bread went down, so we have a new budget constraint. But the indifference curves are now such that the increase in quantity is less. So relative to scenario 1, in scenario 2 we have a inelastic response. Price went down, quantity went up, but by a relatively small amount. Section 6, revisiting the consumer's demand function. Here we will look at the consumer's demand function and how it is derived based on preferences and budget constraints. We look at the substitution and income effect for a normal good, the income and substitution effect for an inferior good, and then we look at Giffen goods and Veblen goods. Alright, here we are going to talk about the demand curve in a little bit of detail, and we look at how the demand curve is derived. This might seem complicated because there are lots of graphs, but if you pay attention, then this is fairly straightforward. On the top part of the screen, what you are looking at is the budget constraint and indifference curves. And if you remember, what we are talking about on the x-axis and y-axis is the quantities. So here we have the quantity of milk, here we have the quantity of bread. This is the budget constraint, this is the indifference line, this is our optimal basket at a given budget and with our particular preferences. Over here we are looking at a demand curve. So this is what we are going to derive. When we talk about the demand curve, if you recall from the previous reading, we have the price on the y-axis and the quantity on the x-axis. Let's say that we want to derive the demand curve for bread. So we have quantity of bread on the x-axis. That means that this axis and this axis are the same. So both cases we are talking about the quantity of bread. But notice that in the two graphs the y-axis is different. Here we have y-axis, which is quantity of milk, and here the y-axis is the price of bread. We are going to derive the demand curve, which is going to show the impact on quantity of bread when price of bread changes. With this particular budget, we have a budget or a income, let's say that's fixed. We have price of milk, which is fixed, and we have a particular price of bread. So initially, let's say that the price of bread is equal to 10. With this particular information, we have a given budget constraint line. So initially, let's say our income is 10, price of milk is fixed, and in our first scenario, the price of bread is 10. That defines a particular budget constraint, and given the consumer's preference, we have a tangent point over here, and let's say that the quantity of bread is 2. So we can say if the price of bread is 10, then the quantity demanded is 2. In scenario 2, the only thing that we change is the price of bread. So let's say the price of bread goes down from 10 to 9. What will happen? The budget constraint shifts. Notice this point stays the same because we are fixing the price of milk, price of bread is down, which means that the budget constraint has moved to the right. We will now have a new tangent position over here, and obviously the quantity of bread is going to go up. Let's say the quantity of bread is now 3. So we can then plot this point where we say that the price of bread is down from 10 to 9 and the quantity is up from 2 to 3. And we can keep going now. We can then say that the price of bread in scenario 3 is down to 8, which means that our budget constraint will shift further to the right. Budget constraint has shifted to the right. We have a new tangency point over here and the quantity of bread is up. So we plot this point. And that is how we derive the demand curve for bread. I don't think it will be easy for the CFA Institute to test this whole concept on the exam, but as long as you understand the general idea, you will be in good shape. Substitution and income effect for a normal good. Again, we will consider milk and bread. Y-axis is quantity of milk, x-axis is quantity of bread. Initially, we have this situation, a particular budget constraint which is based on the budget and the price of bread and the price of milk. We have consumer preferences, a tangency point. So there is a particular quantity of milk and a particular quantity of bread. Now let's say that the price of bread goes down. When the price of bread goes down, two things happen. Bread is cheaper, so consumers buy more bread. This is called the substitution effect. Also, since the price of bread is down, your buying power is higher. So your real income goes up. And when real income goes up, consumers will buy more of a normal good. On this slide, we are assuming that we are dealing with a normal good. So we can say that because of the higher real income, the demand for bread will go up. So this is called the income effect. Now let's look at what's happening over here. We are saying that the price of bread is down, and as we have seen several times, that means that the budget constraint will shift to the right. We will now have a new tangency point, and clearly we can see that the quantity of bread is going up. So initially we were at this point, let's say this point is X, now we are at Y. So this particular distance between X and Y can actually be broken into two parts, and those two parts come from the substitution effect and the income effect. If we take our budget constraint and we first straighten it out so it is parallel to the budget constraint that we end up with over here, and then we say that we slide this budget constraint from here to here. This part where we slide the budget constraint in a parallel way, the impact from that is called the income effect. Because if you remember from earlier discussions, when we talk about purely the income going up, then the budget constraint line does a parallel shift. So the change in quantity due to the parallel shift is associated with the income effect, and the rest is associated with the substitution effect. Now here again, I don't see you drawing this on the exam, so it is important to recognize that when the price goes down, there are two effects, the substitution effect and the income effect. So remember what we are saying over here. If the good is a normal good, then the income effect will cause consumers to buy more bread, given of course that the price has gone down. So notice that both the substitution effect and the income effect operate in the same direction when you have a normal good. Now I want you to do example 6 from the curriculum. Section 6.3 deals with the income and substitution effect for an inferior good. With an inferior good, we know that the income effect is such that if the income goes up, then the quantity demanded goes down. That is the definition of an inferior good. Now let's look at an application over here. Again, let's say we have quantity of milk on the y-axis, quantity of bread on the x-axis. Now we are going to assume that bread is an inferior good. As before, we are going to have two effects when the price of bread goes down. The first effect is a substitution effect and the other effect is an income effect. The substitution effect will always say that if the price of something goes down, then consumers will want more of that good. So substitution effect says that the quantity goes up. Quantity goes up when the price goes down. So remember this fact. Price down, the substitution effect says that the quantity will always go up. But for an inferior good, when the price goes down, what happens? Income effect says the following. Income effect says that if the price of something is going down, then your real income is actually up. And if you have an inferior good and the real income is up, then the quantity demanded goes down. So notice that with an inferior good, the substitution effect and the income effect operate in opposite directions, and that's illustrated over here. This was our original budget constraint, and then the price of bread went down, so we have a new budget constraint line. This was our original tangency point, and this is our new tangency point. Here we have a substantial substitution effect. So from this point to this point is the substitution effect, and notice that the income effect then is in the opposite direction. In this particular case, the income effect, which is in the opposite direction, but the income effect is less than the substitution effect. So the price of bread is down. The quantity demanded though is still up. So the quantity demanded for bread is up. Now there can be a situation where the income effect is larger than the substitution effect. If the income effect is larger than the substitution effect, then that particular good is called a Giffen good. And here I have explicitly written that the income effect is greater than the substitution effect. So here, if the price goes down, then the demand actually goes down. So if this were a Giffen good, then the income effect would actually be larger than the substitution effect, and we would have a quantity that would be lower than the original quantity. If this happens, then our good is a Giffen good. So notice that a Giffen good has to be an inferior good because we have to have a negative income effect. In other words, all Giffen goods are inferior goods, but not all inferior goods are Giffen goods. In the example that I gave here originally, the income effect was negative, but not negative enough to overshadow the substitution effect. So our original item was an inferior good, but not a Giffen good. Recognize that with a Giffen good, if we have a price of the good and quantity of a good, the demand curve is actually upward sloping. Why? Because with a Giffen good, we are saying that if the price goes down, so if you have a particular situation where the price is down, then the quantity demanded also goes down. So if price and quantity are moving in the same direction, that means that the slope is positive. This is a theoretical situation that you will generally see in economic textbooks. It is very hard to come up with an example, a real world example of a Giffen good. So don't worry about it too much from a real world perspective. Just recognize these facts from an exam perspective. Another type of good which might also have a positively sloped demand curve is called a Veblen good. Now, the only similarity between a Veblen good and a Giffen good is that they have similarly shaped demand curves, but the similarity ends there. With a Veblen good, also called a status good, an increase in price increases the value to some consumers, therefore their quantity demanded increases. Now, you have consumers over here who want to show off how rich they are or their status, and they show off their status by buying expensive goods and showing the world that they have enough money to pay for these expensive goods. Now, obviously, the world knows what is expensive and what is not expensive. So for these sorts of goods, if they become more expensive, the price goes up, then people who want to demonstrate their wealth will obviously demand those goods more. So here we will also have a positive relationship between price and quantity demanded. So we'll have a upward sloping demand curve. Here also the concept of conspicuous consumption comes in, where people are consuming just to show the world that they have money. Many students ask the question, or many students get a little confused between Veblen goods and Giffen goods, and again I want to emphasize that they are completely different. For example, we just established that with a Giffen good, the income effect is negative. In other words, if the income goes up, the quantity demanded will actually go down, whereas with a Veblen good, that is not the case. Generally, here with income going up, the quantity demanded will also go up. That brings us to the end of the reading. I'll summarize the main points. You need to remember the three axioms that we started our discussion with, and these are the axioms of completeness, transitivity, and non-satiation. Then you need to understand the utility function and the fact that indifference curves are a graphical representation of the utility function. We talked about two goods, milk and bread. You might have a utility function which says that the utility or the happiness is given by the product of the quantity of milk and quantity of bread. The indifference curves are the graphical representation. They will be convex relative to the origin. All points on a given indifference curve will have the same utility level. The marginal rate of substitution at a given point in time is the absolute value of the slope, and marginal rate of substitution is always written with the x-axis item first, y-axis item second, and if marginal rate of substitution is 2, that means we are willing to give up 1 unit of this, the x-axis item, for 2 units of the y-axis item. A budget constraint tells us our constraint. So a budget constraint typically will be a line like this, where the slope of the budget constraint is given by the price of the x-axis item divided by the price of the y-axis item. The optimal bundle will be this bundle over here, where the budget constraint is tangent to the indifference curve. So that way we will be on the highest possible indifference curve. And to know that you are at an optimal bundle, what you need to look at is the slope of the budget constraint line. That slope of the budget constraint line given by price of x divided by price of y should be equal to the marginal rate of substitution. We then talked about the consumer response to changes for a normal good and an inferior good. With a normal good, when income goes up, quantity demanded goes up. For an inferior good, when income goes up, quantity demanded goes down. You need to understand the distinction between the substitution effect and the income effect. A substitution effect says that when the price of something goes down, then the quantity demanded goes up because the price is now lower relative to the other item. The income effect depends on whether our item is a normal good or an inferior good. And finally, we talked about two special cases, the Giffen good and the Veblen good. Both have upward sloping demand curves. With a Giffen good, we have a very strong negative income effect which overshadows the substitution effect. With Veblen goods, we are talking about status goods where consumers want to show off how rich they are, and therefore if the price of that good goes up, then the quantity that they demand also goes up. As always, I want you to read the summary in the curriculum, review the learning objectives. I have asked you to do all the examples, but if you haven't done them yet, make sure you do them now. The examples are very good. Do the practice problems in the curriculum, and if you have time, then do practice questions from other sources as well. That is it.